Welcome to the SAKSHAM based process control training series. In this course, we will build a complete continuous juice pasteurization and blending system using the SAKSHAM ecosystem and CODESYS automation platform. In today's module, we start with the very first stage of the process, the raw intake system. We need to bring raw juice from a storage tank into the process line, monitor the tank level and make sure the tank never overflows. To achieve this, we will use two powerful blocks of the SAKSHAM Library. DACA block for analog signal scaling, on-off valve block for automation valve control. Let's now move into the CODESYS and start implementing the logic. First, we need to add the DACA block into our fast loop program. From the toolbox, drag a box into the program workspace. Click on the box and then click three-dot menu. Now navigate to the SAKSHAM Advanced Library. Select DACA and click OK. Now the DACA block is inserted into the fast loop program and provide the tag name and click enter. Now in this window, click on the three dot of initialization. Here you will provide all the necessary initialization parameters like PV high limit as 6. Set the value of different alarm. Also provide the tag name and description. This tag will represent the level indication for the tank 101. Once the block is inserted, all the DACA parameters become visible and we can start configuring the signal scaling. We connect the real analog input signal coming from the level transmitter. From the toolbox, drag an input and connect it to the AIPV pin of the DACA block. Now click on the three-dot menu next to the input and navigate to Application HWConfig and Rack 1. Inside the Rack 1, select the AI16 analog input module and add the PV and define the required channel corresponding to the transmitter signal. For better readability, remove unused pins. Right click on the block, go to pin option and select remove unused pins. At this point, the physical analog from the transmitter is connected to the DACA block. The DACA block will convert the 4 to 20 mA signal into a level value between 0 to 6 meters. Next, we add a SOV-SA valve block from the SAKSHAM library. From the toolbox, drag another box into the fast loop program. Now assign the tag name of the block as XV101 and click OK. Now add the real status of the valve input box from the toolbox and click on three dot and select XV101 underscore ZSO of the rack 1 and click OK. Similarly, drag another input block and connect it to the IOZSC. Next, we add a simply safety interlock condition. If the tank level becomes greater than PVHH alarm limit of the LI101, the inlet valve must close automatically. For this, drag an input block and enter the DACA tag name li101.pvhh_ALM and click OK. Now connect another input to the cycle time by dragging an input block and click on three dot. Now expand the advanced library and expand the GBL system tags and select the variable fast cycle time and click OK. Drag an output from the toolbox and connect with CMD. In this, enter the value XV101 CMD. This will send a signal to the valve to close or open the valve. Now, we generate the code and log in into the controller. As there is no error, click login. At this point, the program begins executing in real time. The DACA block is now scaling the sensor continuously and the valve logic is active. Now we connect the logic block to the SCADA Visualization screen for the better understanding. Now open the SCADA project. Here tank and pipes are already present. Now we are going to add the DACA and MOV which we already added in the logic. Click on the current project in the visualization toolbox. In the search box type DACA and drag the tag in the visualization and place it on the tank. Click OK. Now connect the reference in the properties. Expand the reference and BL DACA underscore tag in the front of tag DACA FP. Double click and then click on the three dot to connect it to the tag. Expand the structure as data source object, then data source, application, first loop and select the LI101, that is DACA as we defined in the logic. Similarly, add a SOBSA valve in the visualization by searching and dragging it in the visualization. Connect the reference with XV101. Now to show the level of tank visually, add a level valve from the visualization toolbox. Click on measurement control and drag a bar display to the visualization over tank. Adjust the size vertically. Now connect this bar display to the value. Double click on the column in front of the value. Click on three dot and connect it with the PV of the DACA LI101 and click OK. To set the scale, expand the scale from properties. Double click on 0 in front of the scale start and click on the icon right to the scale start. Below this, double click on the column and connect it with PV low of LI101. Similarly, set the scale end with the variable PVHI. Now click on the generate code as there is no error. Now click on the login icon, click OK and start the device. Now you can see the visualization in front of you. Now to activate the alarm of the DACA, click on the tag name of the DACA. A faceplate will open. Switch it to advanced tab and select all the checkbox in the alarm setting left to the alarm. As here you can see alarm limit which you entered in the initialization of the DACA in the logic. Now click on the XV101 valve, as here you can see the valve is ready and all permissions are OK. Click on the open button from the faceplate of valve. As you can see valve opened and level of the tank begin to rise. Now wait as the level rise to the high limit. As soon as level goes beyond the HH alarm limit, the value goes in the interlock condition and valve stop the flow. In this module, we learned how to access the block from the SAKSHAM library, how to use the DACA block for analog scaling, implement automatic overflow protection, control valve using on-off valve block, visualize the entire system on SCADA. In the next module, we will implement temperature control and pasteurization process using the PID block and control valve. See you in the next episode of SAKSHAM based process control series.